Hi, and welcome to a practitioner's guide to DataOps for Snowflake and how to get there. My name's Guy Adams, Chief Technology Officer for DataOps.live and Snowflake Data Superhero. In the session today, I'm going to cover just a little bit from my perspective about what is DataOps, and then I'm going to take a slightly different angle. And rather than focusing on DataOps from a business perspective, I'm going to focus on how does DataOps benefit me and you as practitioners of DataOps. I'm going to look at some of the key components of DataOps. I'm going to start drilling in on some of the DataOps personas and where people are taking their careers. And finally, for those that haven't started their DataOps journey, I'm going to give some practical advice on taking the next steps. I got into the DataOps space really before it was called DataOps back in 2017, having spent 20 years in the software development industry and developing DevOps and implementing DevOps across organizations, and then 10 years in cloud infrastructure and moving into cloud ops. And when I came into the data world back in 2017, I kind of felt like this. I saw what I'd seen 20 years ago in software and 10 years ago in cloud infrastructure. People were being asked to do more and more with less, faster and faster, with less and less resources, requiring more and more governance, but they weren't looking to those worlds for advice and inspiration. They were trying to take the way we've always done data and make it 5% faster or 10% faster or 15% faster. And the problem was the business wasn't asking them to be 5 or 10% faster or better. The business was asking them to be 200, 300, 400% faster and better with better agility and better governance and faster time to value. And so just trying to do it the way they were always doing it with small incremental improvements was never going to work. And so my move into the data space came from trying to take all of the lessons I'd learned from software development and then infrastructure development and cloud ops over the previous 10 or 20 years and making them fit the problems of the data world. And I think you can really describe, this is my only kind of nod to the business perspective. Businesses are trying to do two things in the data space. They're trying to balance governance, how mature, robust is my process, how much how many checks and balances do I have, what's my auditability and change control and so on, and assurance versus agility. And it's easy to do either of these. It's easy to get great governance if we hardly change anything. And it's easy to get great agility if we don't care about good governance. But historically, organizations have lived on this spectrum where they have to choose one or the other. It's either governance or agility, but not both. And the promise that DataOps delivers is breaking the relationship between these two. You can absolutely have great governance and great agility at the same time. It's not an either or. When I talk about DataOps, I talk about it in this context, and this diagram, which we created a number of years ago, has now been pretty heavily reproduced, and it looks very deliberately like a DevOps flow. And as I said, that's deliberate because we came from a software development perspective. Our approach into DataOps was not let's invent something new. Our approach in DataOps was let's take all of the best things that already exist in DevOps and Cloud Ops, and let's work out where they work well for data, and where they do, let's keep that. And because it's a very well solved problem with a huge amount of investment and time and money and maturity into it, and let's work out where it doesn't work for data. Maybe the way we do things like environment management, maybe the way we do things like automated testing, which necessarily have to be different. But let's just solve those problems on top. Let's not throw everything away and start again just because we have a few unique problems to solve in the data space. And that's always been my philosophy around DataOps, and actually underpins the True DataOps philosophy, which if you want to go to truedataops.org, you can see a more of a philosophical view of this. But DataOps is not a separate thing. If anything, DataOps is a superset of DevOps and CloudOps. It's most of the things that DevOps and CloudOps need, plus some additional data requirements. Okay, so let's talk about how data ops benefit not from the business perspective, but benefits me as a practitioner, as an engineer. So yeah, the business absolutely wants faster time to value, wants shorter development processes and so on. But as an engineer, I like making stuff. I want the minimum amount of overhead and process and the maximum amount of building interesting, useful things. Yes, the business wants happier business users, more trusting business users. They like the fact that things are heavily tested before deployment, and if there is a problem, it can be rolled back with a single click. But as an engineer, I hate stress. I want the release to production to be the least exciting part of the process because I know it's going to work fine. Because any exciting or problematic things that could have happened have already been filtered out by my testing process. So I want that deployment to production to be the least nerve-wracking, the most relaxed, the least exciting part of the process. Yes, the business wants lots of collaboration and lots of concurrent development and so on, and that's absolutely fine. They want to get best value out of their staff, but as an engineer, I just want to spend less time in meetings, less time having to do planning and coordination. Not no time. Agile doesn't advocate that we don't spend any time talking to our colleagues, but it means that we talk to our colleagues about things that are actually useful and deliver incremental value, not about constant planning and coordination. Every time I have to plan access to a development resource or a test resource, or allow a few hours of time because I've got access to the test resource, but the people that use it before me have got it, have messed up its state or whatever. All of these things are kind of pointless overhead and time spent in planning meetings that I just don't need. I want to be able to. I want all of the infrastructure at my fingertips and on demand, so I can just get on and deliver things without overheads of meetings. Yes, obviously companies want the maximum amount out of the staff. They want efficiencies because the hand cranking, which is manual and time consuming, goes away. But all good engineers hate doing manual, automatable work and reinventing wheels. And that's one of the biggest things I see as people come to the data space is this heaving sigh of relief is that we're just getting rid of so much of that manual stuff that we used to have to do. We now have a vehicle and a framework to automate all of that. Yes, obviously costs are always important, and yes, cost savings are important, and increase in efficiency is important. But engineers like being heroes. Engineers don't like constantly being seen as a cost center. The fact that an engineering team can say, yes, we're delivering the same amount for 20, 30, 40% less on our infrastructure costs is huge. And for engineers to be able to go back and say that to the business is nice. Everybody loves to be able to be a hero from time to time. And the last piece is, the business actually doesn't care that much about having lots and lots of individual vendor tools. It does create overhead, it does create operational challenges, but engineers love to be able to use the best tools for the job, but still have everything organized in one place. An engineer hates being told, here is one tool, use it for everything when it's not the right tool. And, that's sort of an anti-pattern for most engineering. So the ability to use the best tools for the job, but still have the efficiency and the comfort factor of being able to see everything organized, orchestrated, and visible in one place is huge for an engineer. Now, the reason I lay it out like this is because when you're trying to implement something new, if the desires of the engineers and the teams on the ground to implement something and the needs of the business line up by 10%, you're going to have an uphill battle. If they line up by 50%, you're lucky and you've got a good chance of making this project successful. If they line up by 75%, that's amazing and this is going to be, a slam dunk. If they line up by virtually 100%, this is a no-brainer. This is something that the business is going to sign off on, and is going to sign off on for good business reasons, and still all of the engineers and practitioners on the ground are going to get what they want out of it. So the fact that the engineers and practitioners get what they want out of it, and the business get what they want, and the fact those two sets line up almost perfectly makes DataOps an incredibly easy thing to get justified in an organization and a really exciting kind of deployment process. Okay, I'm going to talk about what I see as like the four key components to DataOps. So this is a relatively sort of this simplistic diagram, showing our left to right. We've got sources on the left. We've got some sort of ingestion and maybe some testing and quality on the way in. We've got Snowflake as our data cloud in the middle. Increasingly, we've got more and more consumers of that data, whether they be BI tools direct to users, whether they be data science tools, whether they be machine learning tools, whether they be data catalogs and so on, or direct Snowflake data shares. So across the bottom, we've got kind of our data plane. And I see DataOps as being split into the four buckets at the top: automate, orchestrate, test and observe, and develop and deploy. And I'm going to spend just a slide looking at each one of those. So if we look at automate first, to me, automate is all about treating Snowflake as a programmable engine. Think about it the same way that Netflix treats video transcoding servers. Netflix will have a set of configurations and scripts in their central repositories, and when they press a button, that will be deployed across potentially thousands and thousands of servers in tens of data centers around the world. They treat their video transcoding servers and farms as completely programmable engines. Nothing is ever modified by hand or set up manually. To get good data ops and get the value, we need to do the same thing. So, an example of this, we've built an engine we call the Snowflake Object Lifecycle Engine. Basically, it's a completely declarative way to drive every element of the Snowflake infrastructure. And I'll come back and look at this in a minute when I do a demo. But this is, whether it's databases, schemas, tables, users, roles, warehouses, resource monitors, data shares, you name it. If it's a piece of infrastructure inside Snowflake, it can be defined this way as a set of YAML files. But we can define not just the configuration, in this case of a resource monitor, but we can also define things like its grants and permissions. So we define not just the object, but also the permissions that go with that object. And as you see at the top on the left-hand side here, we've also done something a little bit cleverer and said, well, okay, not just define it, but let's make some subtle changes to those configurations based on the environment. If I'm in production, I want a higher credit quota, for example, for a resource monitor than if I'm in QA or if I'm in dev. And every time this is run on our pipeline, the DataOps pipeline takes this configuration, compares it to what Snowflake currently looks like, and will resolve any changes. So if the credit quota is currently set to 5,000 for production, I run this, it will say, yeah, the resource monitor exists. It's there, I don't need to create it, but I will go and update its credit quota, for example, to 10,000. So it will just make the minimum changes to make the target environment look like the source of truth the Git repository says it should be. And that applies to every object inside Snowflake. So that's the automate piece. And that's really focusing directly on Snowflake. Orchestrate is then about the wider ecosystem. So this, often covers batch ingestion, streaming ingestion, Delta ingestion, CDC, whether it's ETL or ELT tools. So it's a lot of it is about getting data into Snowflake, but then it also covers things like advanced processing. I might write some enrichment as a Python script or an R script. I might do some data quality or some data stewardship work using Talend, or I might orchestrate some data testing using Monte Carlo or SQL or something like that. I might be orchestrating with something like Okera for my permissions and security management. And I may be, increasingly, I may be orchestrating with something like a data catalog where I'm taking the rich metadata that I've built up as part of this pipeline and pushing it into a data catalog at the end. So the orchestrate piece is really covering pulling together and tying together an overall end-to-end pipeline that covers everything from getting the data out of the sources into Snowflake, transforming it, testing it, publishing it to our business users, and then making it available to downstream systems, either the full data into machine learning tools or data shares, or the metadata into tools like data catalogs. The third piece I'm going to look at is test and observability. And this is really, as you would expect, more about the visibility about what's going on. So one of the things that we've built into DataOps, that works across a variety of tools is automated testing. It's one of the single biggest things that's lacking in the data world. And one of the single biggest things that DataOps has to bring is that test automation. You can't get the benefits of automatic build and deployment of your data environments unless you've got the ability to automatically test it. Nowhere in the software world would we conceive of developing a software product and deploying it without testing it. And yet in the data world, that happens, every 50 minutes. Someone will ingest some new sales records and just make it available to the business users and say, well, it's probably okay. And if it's not, the users will tell me. That's not how we want to be deploying data products in the future. When we deploy them, we want to know and assure and be able to prove that that data was good before it went to the business users. So automated testing is a massive part of this. And as part of that, we build in a publication step. So if the automated testing in the pipeline doesn't work, if it fails for some reason, we can stop the pipeline at that point and say, let's not publish it to my business users. I'd rather my business users have data that is, say, 15 minutes old that I know to be good than data that's 2 minutes old that's just failed my automated testing. I'd rather my users have slightly older good data than up-to-date bad data. And as part of this layer, we've got a whole variety of governance reporting about what's going on inside Snowflake, about the roles and permissions management, and all of this, because it's attached to pipelines, all these reports and all this data goes back in time. So I can go and any of these questions that I can answer now for a pipeline that just ran, but I can also answer for 3 weeks ago last Tuesday at 2:30 in the afternoon, because all of the reporting, all of the observation I'm doing is attached to a pipeline execution, which gives me, out the box, great governance in terms of what happened when. So those three things, the automation of Snowflake, the orchestration of the ecosystem, and the end-to-end test and observability, those provide kind of the building blocks of a pipeline and what a single pipeline will involve. But of course, if we want to get any of the real benefits of DataOps, we've got to have really great environment management. And that means our development and deployment processes have to be outstanding. And we line this up very much with Git methodologies. So we line up each of our branches in the Git repository with an environment inside Snowflake. So when I run the master branch, I'm going to do a whole bunch of the things we talked about, a whole bunch of automation, a whole bunch of orchestration, do a whole bunch of automated testing, record a whole bunch of governance and metadata about that pipeline. And I'm going to produce or update the production environment. But everything I'm doing is targeting inside Snowflake, that production environment. Then when I want to do a piece of work, I might cut a feature branch, and that will give me a complete copy of my configuration and code, as you do with a Git branch. And when I deploy that inside Snowflake, it will dynamically create a feature branch environment named the same thing as my feature branch in the Git repository. So now I have what for a practitioner, for an engineer, is the holy grail. One of the reasons that software engineers are so much more efficient than data engineers is because a software engineer, when they cut a branch, has the ability to make a change, test it, make a change, test it, make a change, test it, without worrying about what am I breaking, without worrying about how much is it costing, without worrying about where I'm going to get test resources from. That's just kind of built into the process. What we've done is develop the same thing for data. So as an engineer, I cut a feature branch, and when I run that, I know it's going to create a completely sandbox environment inside Snowflake for me to test my results in. And not just test them for myself, I can give access to stakeholders, I can let them review the results to make sure they're happy, so I get that interaction as well. So I develop my new feature, and using all the components, these is an example set. Once I'm finished with that, I'll probably merge it into dev, make sure my changes haven't broken, make sure they're still compatible with other people's changes. I'll get a peer review on that. Then I'll do a pull request into or a merge request into QA, get some more peer reviews on that, more automated testing at every single stage. And then finally, we'll deploy into production. And as I said, that deployment stage is the least interesting, the least exciting, the least worrying, because I tested it all in my feature branch. Then I merged and tested it all in a main integration branch like dev. Then I tested it all in a QA branch. I've had multiple other people look at my configuration and code and check I haven't done anything silly. So when I deploy it in production, I am very, very relaxed that this is going to go well. However, there will always be the one time in a million where, despite everything that you've done, something goes wrong. And a good example of this is it's nothing to do with your change, but some downstream system was not expecting it, and actually your change is completely fine, but it's caused some downstream system to break, and the business starts screaming and saying, "Hey, what's happened? It's broken something else. We need to revert back." And so that's one of the things when we talk about environment management inside DataOps, it's really critical. We can't just think about how we deploy new stuff. We've also got to think about rollback. And so that's something that we've built into our DataOps platform very much is we know how we do the revert from a Git perspective, so we can revert our configuration and code back, but then the automated ways that we can use things like Snowflake time travel to revert our data back, our data product back to the same point. So this gives us that, that ability as an engineer to sit back and say, well, I know that there's only a 1 in a million chance it will go wrong. I'm very confident this release will work fine. But if it does, I know that I've got a tested, robust process to get me back to a previous point, and I can use it anytime, with a couple of clicks, and then I can go away and work out what went wrong, and I can solve it in slow time. So again, that gives me as an engineer, as a practitioner, the comfort that I'm not going to be under huge stress trying to fix something live in production, which is, as we all know, the worst place to be. So let's take a very quick walkthrough and just look at a bit of this in practice. We've seen some screenshots, but let me switch over and look at the actual DataOps platform. So this is one of our test projects, one of our demonstration projects that shows kind of a relatively standard infrastructure, a relatively standard pipeline. I'm going to look at some of the historical pipeline runs here, and I'm going to pick a master branch. So this would be deploying into a Snowflake production environment. So I'm not going to go through all of the jobs in this pipeline because it's a pretty comprehensive set, and I'm just going to pull on some of the key ones. So the first one here is initialize reference projects. Particularly in larger organizations, I'm going to have some element of standardization. I'm going to have, within my project, I'm going to inherit from other projects or a central project because there are things that the company wants to standardize. I want to reuse components that have been generated centrally, save myself time, make sure I'm doing things in a standard way. So that all happens at the very start of the process. Then, to keep my security team happy, I'm going to integrate with AWS Secrets Manager or Azure Key Vault or an Enterprise Secrets Manager so that I don't have to store passwords anywhere. I can use a proper secrets manager to make sure all that stuff's safe. Then I'm going to do a bunch of preparation work. The most important job here is that one I mentioned before, the Snowflake Object Lifecycle Engine. And just to drill into a little bit more about what that configuration looks like, I looked in my example at a resource monitor, but this is how it looks with roles and data shares and users and warehouses. And if I go up here, I will see databases and schemas and stored procedures and file formats and stages and dynamic masking policies and row access policies and so on. Basically, every object that you could want to create inside Snowflake, you can do as part of the Snowflake Object Lifecycle Engine. So every time this pipeline runs, every time this job runs, because the master branch is looking at the production environment, it's going to be looking at the production environment inside Snowflake and saying, does it match this configuration? If it does, there's nothing to do. If it doesn't, because I've made some changes, it will go away and it'll dynamically build the DDL statements just to affect those changes while maintaining the state of all of the objects. Then I moved to sort of batch ingestion, where you can see a lot of this is orchestration. We've got Matillion and Fivetran and Stips and Informatica and Talend and pretty much any sort of standard ETL, ELT tool out there as your data factory. Then I typically advocate some testing. If we've just ingested some data, it makes sense to test it before we move any further. So let's go and do a testing stage. Then we start building up the layers of our data warehouse, and you can use these using Kimball or Snowflake topologies or Data Vault topologies or data marts. We are agnostic to the way that you actually design and build your layers, but you are likely to want to build some layers, then do some advanced processing, maybe some enrichment, then build some more, then do some testing, then build some more. How you build this is, of course, entirely up to you. And then you're going to get to this publication stage. And this is where we say, if everything's worked up to this point, we're going to publish to our business users. If something up to this point is broken, we're going to stop. We're not going to release it, and we're going to go work out what went wrong. And even after that publication, we've then got all these metadata actions. So whether it's generating the role explorer, so I know that who has access to which role and which objects do they have, whether it's a security report about how many people have logged into Snowflake recently and what method do they use, whether it's grabbing all of the metadata from this pipeline, assembling it and pushing it into a data catalog to massively enrich what the data catalog can show to a user. These are all kind of the final stages we take. And that last data catalog piece is becoming massively important because a data catalog is supposed to give the business users all of the information they need about the data to make their decisions. And you think about your automated testing as a simple one. I've got all of the automated test results here from an engineering perspective, and I can drill into these, but this is not a business-facing tool. If I'm a salesperson making forecast against some of the or making decisions against some of the sales forecast data, I want to go in here and know the tests that have been run against that data and whether they passed or not before I go and make my business decision. And I've got access here to some of the reports. So for example, I've got my standard modeling and transformation report here, where I show the lineage and all of the different layers that have been through. So if I look at something, for example, like this, I can see this is some of the data vault modeling that goes through. I can look at my what was my Snowflake login history. So it's a simple auditing report showing who's logged in from which IP address to Snowflake, and I can keep that every point in time. Or some more complicated things like the role explorer, where I'm able to pick a particular object or user or role and filter. So if I pick a particular object here and just say filter, I can see every user that has access to that object and what hierarchy of roles they went through. I've got an infinite number of ways of exploring this. So these are just some examples of the sort of reporting that we get out of the pipelines, and a lot of this really leads to that great governance. Okay, so a very quick walk through the system. Didn't have a huge amount of time to do that. Um, the last thing I wanted to look at is a bit about the DataOps personas, because this is something that really a lot of people are still struggling with, and it's something that's developed massively over the years. So if we want to look at how personas are developing in DataOps, let's go back a bit in time. When I ran a software development organization, I had multiple teams. Each one may have had an architect and a set of engineers, and then I had a DevOps team. And I had one DevOps team that supported all of those software engineering teams. I had a much smaller number of DevOps engineers that did things like they standardized the tooling and the approaches. So every team is working in a fairly consistent way, particularly the standardization of things like test frameworks They did all of the infrastructure management and automation, so every team got the infrastructure they needed exactly when they needed it. They built and maintained the CI platform, the CI/CD platform, so every the teams could just use it. They were responsible for monitoring and performance management of all of the shared infrastructure. They managed the reusable components. So if one team developed something that they thought other teams could be useful, could find useful, that went through the DevOps function to build a library and a catalog of those. But also, they're the DevOps champions and the coaches. Yeah, there are obviously some of the software engineers are going to be more DevOps focused and savvy than others, and that's fine. Typically each team had their own nominated sort of DevOps expert, so there became a little community. There was the DevOps engineers are the champions and the coaches, and they support all the teams. But within each of those teams, they've got some specific people who are more interested and more capable in this area, who they will then support, who will in turn support the rest of the team. So it becomes very much a kind of a federated model. And what that means is that you can support some pretty large teams. So I had, order of magnitude 190 engineers in teams for less than 10 DevOps engineers. So we're talking about an 18 or 20 to 1 ratio between the engineers building the value every day and the DevOps engineers providing all of that support for them. Then if you roll the clock forward, I really only have to change the labels to describe the CloudOps function as well. A very, very small CloudOps team with a few CloudOps experts was able to support a very large team of software engineers doing deployment onto AWS or Azure or whatever the cloud platform was. So if we want to make a prediction, and the prediction I made 2 years ago about where DataOps was going was something like this: to say we would have multiple teams where we'd have some data scientists and some data architects and some data engineers, and they may well be embedded into business teams, so they'll have business users as well, non-technical users, but they would be supported by a central DataOps function, which had a small number of DataOps engineers, but they're doing exactly the same thing: standardizing tooling and approaches, building and standardizing test frameworks, doing all of the infrastructure management automation, maintaining the CI/CD platform, doing the performance management, managing reasonable components, and ultimately being the foremost authorities when they're in their companies of what is DataOps, particularly because it's a much newer area and much less well understood, understanding what DataOps is all about, fitting it to their company, and then becoming the champions of that and the coaches to those other teams. And that's what I kind of predicted was going to happen 2 years ago. But at the time, there was nobody with the name DataOps in their job title. There were no DataOps engineers. When I did a search a couple of weeks ago, just in the United States, and I searched for DataOps, there's well over 1,000 job postings on LinkedIn specifically for people doing DataOps, with DataOps as a job title. So that gives you some indication that this model is actually happening. And in fact, we are supporting multiple large organizations who are building a central DataOps practice, a center of excellence. A lot of people call it a DataOps center of excellence within their organization that is following exactly this model. One small expert team of people, maybe even only 2 or 3 people, supporting a massive wider population and wider community of data engineers, data scientists, data architects, and being incredibly efficient and successful at doing that. Okay, so the final thing, if you haven't yet got on this journey, or you want some help doing it, a couple of things that you can do. One of the biggest problems that people start out with is, this is great. As an engineer, I get this, but help me sell it to my boss. Help my boss understand this, and help me help my boss take this up the chain. How do we justify it to the business? So I'm not going to read through all of these, but just quantifying 4 key areas that the business will understand. Also 5 key areas the business will understand in terms of key values and the key benefits for engineers. If you can go to and say, look, here's 5 benefits for the business, 5 benefits for the engineers, that's almost always enough to get started. The next thing you've got to do is choose how you move forward. Don't try and boil the ocean. Don't say we're going to end it. We're starting to start a 6-month procurement process and we're going to do all this stuff. That's a very non-agile, non-DataOps way to do it. The best way to get started is to get started. Ask for approval to run a pilot project for 4, 6, 8 weeks. Choose a partner, choose a technology, pick a single representative project, and just get in and do it. You're going to learn so much more and be able to prove so much more to the business about the value by getting in and doing something than you are with tens or hundreds of PowerPoint slides and numerous kind of paper exercises. So just do the minimum amount to get your kind of pilot approved, and then use the results of the pilot, which will be successful, to then take the next step. Once that's successful, you take the next step. And this is what we've helped multiple companies through this. And within 6 months, DataOps is now a completely institutionalized part of the way that they're doing business. And they're rolling it out. It's been signed off at senior management, and it's now being rolled out as the way that we do business. Some other next steps that you can do. I've got a link in a minute to get a free copy of the DataOps for Dummies book, which is a good primer, a good guide. You can sign up for DataOps.live via Partner Connect and have a play. And you can also reach out to us, and we can show you how we can help. So we are a Snowflake Premier partner. There's a blog where we write about all sorts of interesting things related in and around DataOps. I mentioned previously there is this microsite on the philosophy of true DataOps. So that's not so much the technology, but the philosophy that sits behind it. There is a QR code here, which allows you to download a copy of DataOps for Dummies, which was created by some of us here at DataOps and a range of other industry experts. You can reach out to me either personally at DataOps.live or via our main information mailbox. And finally, and maybe most importantly, come and see us. We're going to have a big stand at Summit. We're going to be demonstrating all of the things I talked about today, but in much more detail. And we're going to be announcing and showing some new stuff that we don't have, that I wasn't able to talk about today. So come and see us at the Snowflake Summit. Look forward to meeting you there. And finally, if you do want a further incentive to take something into business, we are currently running a guaranteed success program. So for the first 25 customers that sign up, this is a very, very specific program that gives you an unlimited DataOps license, training, professional services. It gives you access to our 70-page Center of Excellence blueprint. But most importantly, it's access to our team of experts and architects to help you both from a technical perspective, how to get started in DataOps, but then also from an organizational perspective, how to fit it in with the way that you're doing things. So again, if you're interested in that, please reach out to me at either of these email addresses. And that's it. Thanks very much for listening. Bye-bye.